From next-generation fighter jets, drones flying and fighting together with human pilots, the air domain is changing pretty fast. And new technologies, new strategies, and entirely new ways of fighting are reshaping what air dominance will look like. And so in this episode, I'm talking to Justin Bronk, a military aviation expert, to understand how exactly will that happen. We dive pretty deep into the recently revealed American and Chinese 6th-generation fighter jets. How will they change the air warfare? Who's ahead in the race for air dominance, whether Europe should develop its own next-generation fighter, and whether Russia could catch up, and how other technologies, like the collaborative combat aircraft, basically swarms of drones flying together with human pilots, are going to change what air combat has looked like for decades. This is a pretty fascinating moment in the evolution of air power, and today we'll break down what's already a reality and what the future might look like. The corporate partner of this podcast is Conductor, which provides software for crisis exercises for everything from cyber threats and supply chain security to hybrid warfare. And if you care about geopolitics, and I assume you do since you're listening to this, you should really have a source that helps you filter all the noise from the stuff that actually matters. And that's what you get with my newsletter, where I break down geopolitical stories that actually matter and explain why, and where I try to provide real signal and real intelligence in your inbox and completely for free. You can find the link in the description. And now, enjoy the conversation. So, welcome back to the podcast.
Thanks for having me.
So this time I want to talk a bit more about the future of air power. We're going to be talking about the 6th-generation fighter jets, but I think maybe as an introduction to that, something that I was wondering about sort of watching all the new developments, it seems to me like specifically the air domain, the technology and the strategies and the way the way things will work and how combat will work in the air domain. It seems that all of that is transforming really fast and probably a lot faster than in any other domain. At least that's my impression. And I was wondering if you have the same impression, if you think that assessment is correct, and if it is, why is that?
I must admit, I'm not sure I would characterize it quite that way. Essentially, I think the nature of combat in the land domain has actually changed more radically, in the sense that the impact of large numbers of small UAS, but also loitering munitions, an explosion of kind of tactical EW equipment in terms of production of very large amounts of it, has pretty fundamentally, I think, changed the way that armies need to equip themselves to at least defend themselves against enemy forces that use massed UAS in that fashion, but also, for example, kind of changed the way that basic things like artillery work, because large numbers of loitering munitions, such as the Russian Lancet 3 or Lancet 3M, mean that the risk of counter-battery fire, even if you are using systems which traditionally might outrange or at least be able to suppress enemy gun lines, means that you're going to struggle to concentrate guns and build up a sort of sufficient ammunition supply line in an operational sense against an opponent that's using loitering munitions in that kind of way, unless you have very, very robust counter-UAS capabilities. Even if you can protect the guns themselves, if you're looking at sort of traditional sort of mid-echelon fires with massed guns, the ammunition supply that you would require to keep those guns putting out the sort of volumes of fire that you might expect in kind of divisional scale warfare would be highly vulnerable. And so that probably puts a higher premium on either potentially precision munitions, such as bonus type rounds, for example. But the problem there being that the EW tends to degrade the effectiveness of those rounds, and you've seen certainly the GPS guided Excalibur shells pretty much ceasing use in Ukraine because the effectiveness has been degraded to that point where it's not worth it. Or potentially going towards things like cluster munitions again with DPICM and other munitions natures there. So I think it's a pretty significant transformation of ground combat. Certainly in Ukraine, albeit Western militaries would try not to fight like the Ukrainian military is having to fight or the Russian military is choosing to fight. But the way that they would try and avoid it would be primarily by concentrating on maneuver warfare enabled by air superiority, and then you're back into the air domain. Where the air domain, I'm not sure it's actually changed as fast as people think. It's just that we've got a lot more operational data on some of the threat systems. The Russian, for example, ground-based air defense network, which is the primary constraint on NATO air power in Europe, most of those systems have been around for at least a decade, probably more. And we've known quite a lot about them. I mean, I remember as a junior analyst looking at, S-400s and SA-17s and the 27 that was coming into service, so the later model books, the SA-15s, the Taurs. It's all the same stuff, and they are a bit more able to use it as their doctrine used to say they should than they were, but broadly speaking, it hasn't changed that much. And if you look at the sort of systems that we're employing, F-35, Typhoon, Rafale, Gripen, GPS-guided munitions, some with millimetric guidance to allow active acquisition of moving targets, laser guidance, data links to kind of track data and situational awareness between aircraft. Again, all of this stuff's been around a long time. Even F-35 is now not a young aeroplane. And so as we look towards kind of sixth generation programs for the 2030s, I mean, the ability of threat systems to share radar data has qualitatively changed, and the ability of those threat systems to be reprogrammed rapidly or to reprogram themselves rapidly so their signature changes, and it's more difficult to do passive positive ID detect and track and countermeasures generation in the traditional ways. That's a bit different. But of course, the same sorts of processes are happening on the other side in terms of improving the ability of electronic warfare suites to react to and detect complex, rapidly changing signals, and for analysis cycles to try and keep up using, for example, AI or machine learning enabled tools, which are brilliant for electronic warfare analysis because they're very good at finding doing change detection or anomaly detection in very large data sets, which is a lot of what you're doing in signature analysis within ELINT gathering data sets. All of that stuff is a bit different. I think the net result is probably of that ability to share sensor data much more freely among adversary and friendly systems. Also across domains in a way that we couldn't necessarily do reliably, at least outside niche bits of the US Air Force or US military. So, for example, sharing space-based observational data with aircraft in flight, or maritime radar data with aircraft in flight, passing aircraft tracks down through kind of adaptive, should we say, like Babelfish, they're often called, but like relay nodes, translation nodes, down to ground flyers to be able to use artillery in support of, if it's available, in support of air operations, and actually also use air observation to enhance the lethality of ground-based fires. Again, none of it's enormously new, but what it's done is allow the development of some significantly longer ranged capabilities. So you're seeing a resurgence in very long-range air-to-air missiles, very long-range surface-to-air missiles, very long-range air-to-surface missiles, which are generally relying on, to be used at the kind of maximum ranges that they can be used, are generally relying on data from a third-party source for at least part of their flight, and probably the terminal phase, unless they have an active seeker, but at least part of their flight, because their ranges are so far in excess of what the launch platform, whatever it is, ground-based or air-based, what the launch platform's own sensors can see. And that is a bit of a change. And you're seeing that, therefore, a greater emphasis on large aircraft, it seems, for GCAP in the UK, Japan, Italy program, particularly the Chinese F-47, the American F-47, the Chinese, what we're calling J-36 at the moment, less so that what people are calling J-50, the Shenyang one, but certainly the very large Chengdu J-36, so-called. And that very large size is a function of both the desire to be able to carry those very long-range air-to-air and air-to-surface munitions internally. For a stealth aircraft, everything has to be internal. So if you want to carry longer range weapons, they generally are larger. Therefore, you have to have a larger weapons bay. Therefore, you have a larger aeroplane. Therefore, you need more fuel for more powerful engines. So the aircraft gets larger again. So I think that's a change to a degree. And also a desire for more range, which is, again, pushing that increased size and therefore weight and therefore cost. Because those long-range missiles and kind of multi-domain kill chains will make it harder and harder to put tankers or keep forward air bases alive and functioning close to the fight wherever it's happening. But yeah, I think it's more evolutionary actually rather than revolutionary in the air domain. Whereas in the land domain, you could argue that the large-scale use of UAS, loitering munitions, and to some degree unmanned ground systems now, coupled with that, the persistent ISR that it brings has, at least for the Ukraine conflict, pretty fundamentally changed the nature of land combat.
Just a quick break here to let you know that the corporate sponsor of this podcast is Conductor, which provides software for crisis exercises for everything from cyber threats and supply chain security to hybrid warfare. Thank you, Conductor, for sponsoring this podcast. And now, back to the conversation. So it's good that I'm able to confront my impressions with people who actually know what they're talking about. We've already ventured into the both Chinese and American and 6th generation fighter jets. And you've hinted at how they're going to be different, but maybe to explore both of them, first American and then Chinese, in more depth. I think it's still quite limited what we know about the American F-47, but the head of the US Air Force said about the F-47 that, I'm going to quote, "The capabilities it brings to the fight are game-changing for us. It changes the character of the fight for the entire joint force. It allows us to get places where we otherwise couldn't, encounter the adversary in ways that we can't now." So what does he mean by that? And what is he talking about in terms of what do we actually know so far about the F-47, given that a lot of it has only been recently announced, and most of it is still classified. So I guess a lot of it will still be speculation.
Yeah. So there's a few things that we know in the open source. First and foremost, as mentioned, that the F-47 will have significantly greater range. So that being combat radius on internal fuel than previous generations of tactical fighters. Because tactical fighters in their current guise do not meet the US operational requirements really for projecting air power at scale. And that's the reason you would want tactical fighters rather than, say, B-2 or B-21 as it comes in, because tactical fighters give you that scale and multi-role capability, I guess. They existing tactical fighter fleets really don't bring the organic range, i.e. how far they can fly from a tanker orbit, that the US is likely to require in a large-scale conflict with China in the Indo-Pacific, because China has such a powerful and sophisticated and multifaceted missile arsenal that it can very credibly threaten to render pretty much unusable most of the main air bases within the first island chain that US air power might try and stage from, and can also increasingly threaten tankers, airborne tankers, a very long way from the Chinese mainland. And that's using both airborne assets, so J-20 most notably at the moment, with long-range missiles like the PL-15. They have some even longer-ranged air-to-air missiles that are in the open source, so things like the PL-17 that a lot of people call it. It's a very long, very low drag air-to-air missile that's been seen a few times on J-16, so the Chinese-derived flanker. That again would be relying almost certainly on some significant off-board targeting assistance, so using sensor feeds from other platforms to help guide the missile in flight. But the missile itself, if you launch it from the sort of speeds and altitudes that a flanker like the J-16 can take them to, you're looking at probably in the 400 kilometer or plus range against something like a tanker or an AWACS. And so there's also some more sophisticated capabilities in multiple domains, not just the PLA Navy, but of course that's a significant thing given how many ships China is building, how many sophisticated missile systems they have and radars they have on board. The surface action group threat is a really integral part of that air denial capability that China is building. It all comes together along with some more sophisticated stuff on the ground that generally sits at higher classifications, that it's meaning that the US will be taking more and more risk to put a small number of tankers, even hundreds of nautical miles from the Chinese mainland, or from, say, Taiwan, if they were looking to try and defend Taiwan against some sort of invasion from the PLA. And so it would be pretty inconceivable to me if F-47 wasn't being designed with very significantly more internal range, to be less tanker dependent, to be able to not just get further from those tanker orbits that will be further and further back, but also to be able to stay longer when it's there. And, to not just, if you let's say you could go for pulling a number out of thin air, 400 nautical miles from a tanker, and then get 400 nautical miles back with a bit of fuel reserve, but you could only stay on station 15 minutes. That's not really particularly useful, or at least it might be useful, but you'd have to plan it very, very carefully against a very specific, well-known, well-understood, well-timed threat. Whereas if you could do the same thing and put a vol there for 2 hours, that would be a very different capability. But of course, then you need 2 hours combat loiter fuel, plus presumably a significant amount of additional reserve, because if you get into actual combat, typically you'd be using afterburner and other things to give your missiles more energy as you fire, and also to make it easier to evade enemy missiles in terms of getting out of the way, shall we say, when you've been engaged. But of course, afterburner uses a huge amount of fuel. So, I would say F-47, a lot of internal fuel compared to frankly, the F-35C has a lot of internal fuel. It's just shy of 20,000 pounds, which is a lot of fuel for an internal carriage load. So if you're looking at significantly more than that, and you must be, because as far as I understand it, F-47 will be twin-engined. So if you want greater combat radius than an F-35C, which is about 600 nautical miles. If you're pushing up towards 1,000, but with two engines that are probably more efficient, but higher thrust rating in coordination and are generating more electrical power, you'd be looking at a really serious internal fuel load, plus that big weapons bay for those long-range air-to-air missiles and potentially air-to-surface missiles, plus all the sensors that you're going to need to make that system able to take full advantage of its positioning and weapons load in a heavy electronic warfare environment. So it's going to want to be, the designers are likely to want it to be, and the Air Force is likely to want it to be pretty organically lethal, not just relying on off-board target data. Of course, they will want it to be able to take and exploit off-board target data, but they'll want it to be able to be pretty lethal on its own, especially given how far forward they might want it to be and how contested that sort of combat area will be in terms of EM spectrum. So some pretty hefty sensors with quite a lot of power and cooling, therefore. I just don't see how you end up with an aircraft that isn't, potentially of a similar size and scale to China's, what we're calling J-36. So kind of 50 to 55 ton max takeoff weight ish, which will lead to a very, very expensive airplane. I mean, and we also know that F-47, they will want it to be significantly more stealthy across significantly larger bits of the radar spectrum. So traditional stealth fighters, F-35, F-22, J-20, are heavily optimized around stealth in the X band with a little bit of the KL crew. So there's a reason for that, which is that those are that's the bit of the radar spectrum that fire control radars typically use, because it's the right balance for the sort of aperture size that you can put in the nose of a fighter, while also giving decent range and decent resolution with the sort of power levels and aperture size that you're dealing with. So, they didn't pick it out of nowhere. But there are a significant number of threat systems these days, particularly with those multi-domain options for sensing and guidance, that work outside the X and the K or Q bands. So, for example, you might theoretically take a few different relatively long-wave radars, which would give you better range for a given amount of power, but also interact differently with stealth shapes, but traditionally would give you much lower resolution, so it might not give you enough resolution to guide a missile, for example, even though it would tell you that something was there. You might take a few of those, look at a target from different sides, and using modern computing power, essentially, and data links, put those together to create a multi-static, so multi-view kind of picture, which collectively, with that post-processing, particularly now you're seeing machine learning or AI-driven tools that are helping make that better, you potentially generate a weapons quality track from that kind of approach. And so this is likely the case for both J-36 and F-47, and probably for NGAD and later SCAF and other next-gen programs too. There will be a desire to make them very low observable, not just in the X and KLQ bands, but also in a wider part of the spectrum. And that drives you down different shapes. It makes it much harder to preserve traditional kind of fighter-type maneuverability, because that typically requires at least canted vertical tail surfaces and or thrust vectoring, but typically canted vertical tail surfaces to maintain stability at higher angles of attack, and in kind of, if you're really throwing it around, there's some pretty crazy aerodynamic corners of the envelope you have to remain in control in, especially at very high altitudes where the air is very thin, and so control surfaces tend not to be as effective for a given size. I mean, if you look at the F-22, it's very, very stealthy, but it has enormous vertical tail surfaces. If you're trying to be stealthy in other bits of the spectrum, it helps to be bigger, it helps to be longer, and it helps to not have vertical tails, among many other refinements. But that will drive you down a different design philosophy, probably. And it will also make it, again, more expensive, because VLO, or very low observability, is just inherently very expensive. You have to maintain these things in very good condition. The shapes that they have to be, and the cleanness that they have to be in terms of the fit and finish, means that maintenance, for example, is typically more of an issue, because even if, for example, the F-35 has been designed with maintenance in mind, despite the fact that it's notoriously expensive and complicated to maintain, that is despite the fact that it was designed to be as easy to maintain as they could make a stealth aeroplane. So, for example, most things are line replaceable units where they can be. So, for most maintenance tasks, you don't generally have to dismantle multiple systems to get to the thing that you're trying to maintain. You just have to generally open one access hatch or a couple of access hatches and pull out a couple of things and replace them. It's still difficult, not just because of supply chain issues or whether you have those spares, but also because then once you close the hatches and things again, access panels and things, you then have to seal them with radar. You have to basically repair the radar absorbent and radar reflective or whatever. Sorry, not reflective, but the RCS coating, and cure it, and that takes time. And it's they're difficult chemicals to work with in some cases. So if you expand that up to a much more complex aeroplane that's much bigger, the maintenance costs are unavoidably going to be high as well. All of which is to say that one of the issues with F-47 and one of the reasons why there was this pause and the USAF looked at pausing it and reviewed it and ultimately came back and said, yes, we do need it, I suspect is because their fighter replacement program was essentially unaffordable before NGAD or F-47. Their fighter force is now on average about 30 years old. If you look at the airframes that the US Air Force operates, and they're just not able to buy enough airplanes each year to replace airplanes at the rate that they're wearing out, having to spend increasingly more and more and more on sustaining an increasingly aging and worn out fighter fleet across most of their fleets. And so given that they already had those issues and they're trying to replace 480 tankers across the reserve, the reserve, the Air National Guard, and the active force, and they're trying to replace the land-based ICBMs and renew all the silos, the Sentinel program, which is monstrously expensive, and they're trying to recapitalize the bomber fleet with B-21. And they need to replace the E3 with both an orbital solution at some point and the E7 as a kind of interim solution. And there's helicopter replacements they need to do. And you see the issue that, and they're needing to upgrade their F-16s. So they're retrofitting them with better coatings, with modern radars, with new consoles. There's all of this work they're trying to do. And so if they're trying to do all of these things near simultaneously while dealing with an ever more expensive and aging fleet, and trying to increase capability, not just maintain, because they need to go against, they need to be ready to fight the PLA, which are ever more capable. It is a difficult thing to work out how you bring in a very stealthy, very large, very sophisticated new combat aircraft. We can call it a fighter, but it's probably more multi-role than that, even though the focus will be overwhelmingly on air superiority. And so, however much they try and de-risk the development program, and they've done a lot of work to try and de-risk it. So, there have been demonstrators of prototypes flying for a number of years already. Significantly longer demonstrator program with more data, therefore likely collected than any previous one. So if you look at XF-22 or X-35, they flew for about a year each, and so there's been a significantly longer demonstrator maturation process. They're probably going to try and use as many mature technologies as they can, but the basic math still comes out as if you're going to do something with a roughly 1,000 nautical mile combat radius, broadband VLO capabilities, long-range weapons, unprecedented sensor performance, and it's new, you're going to end up paying probably north of $300 million, possibly well north of $300 million per airframe, and it's going to cost you multiples of what even an F-22 costs to fly per hour. So probably somewhere in the region of $180,000 to $200,000 an hour to fly. And so however much you need that capability from an operational requirements point of view, and they do seem to need it, it's a pretty tall order to ask how to fit that into a fighter program that is already unaffordable and in crisis, bluntly. So you can see why there's been all this controversy around it. For my own part, I think they do probably need it. And ultimately the answer might be, especially given this administration's significantly marked apparent desire, at least, to do less expeditionary stuff in other parts of the world. There's discussions about shutting down AFRICOM and merging North and South comms, other things. You might have to start trading off mission sets in other areas. So, for example, looking at significantly downsizing permissive ISR fleets or rotary fleets, let's say, in order to make more space, as it were, for your combat air. We sort of have a tendency to view force structures as inherently all required and therefore fixed, and therefore all trade-offs as kind of taking place within their own category. But it is worth remembering that as a result of those very long counterinsurgency campaigns for 20 years, pretty much 15 years, one of the consequences was a significant downsizing in terms of proportion of force and proportion of spend, not just in the US, but in European air forces as well, away from combat air and towards essentially mobility, ISR, and rotary lift, because that's what we needed in primarily in those conflicts. But if you can't meet the combat air requirements for your peer threats, for air superiority in what is an increasingly dangerous outlook, maybe actually you need to start making some pretty significant shifts in that balance of investment.
If you're enjoying this podcast, chances are that you like to know what's going on in the world of geopolitics. And if that's the case, you might want to sign up to my newsletter. There's a lot of news on geopolitics, but most of it just doesn't actually matter. It's just chasing headlines, emotions, and breaking news. What I want to do is to try to separate all this noise and find the signal, the stuff that actually does matter and will have consequences months and years down the line. And so in every edition, I pick out 3 things that do matter and explain why and what will be their future impact. You can find the link in the description, so check it out and sign up to stay informed. So I think that's so interesting because it does kind of go against the long-term strategy that I've assumed was in place of that basically the US Department of Defense saw as an issue that they do tend to build less and less of more and more expensive, exquisite equipment, but for a conflict with China that they're very obviously preparing for, you would likely need maybe more of a quantity rather than quality. And what you're saying is that it looks like the F-47 is going to be an amazing piece of equipment. It's going to be an amazing combat aircraft, but it's going to be extremely expensive, and they will likely struggle to maybe both afford but also build it in large enough numbers that they would maybe need. So basically, I guess, how do you think maybe that the introduction of the airplane will change the strategic thinking in the U.S. Air Force and in the U.S. military at large about how it uses the Air Force and how it prepares the for the conflict with China? And the way what you were saying is that they would likely be forced to massively cut other capabilities, maybe even in other branches, so they can actually afford to build this and purchase this in higher numbers. Is that correct?
Yeah, broadly speaking. I mean, I think first and foremost, your point that you touch on there of the balanced investment between the services, it is weird to me that the US Air Force is utterly integral to the warfighting plans for the US anywhere, in any context. It's the kind of unifier, the US Army would have a greater lead in terms of proportion versus, for example, the Navy in the European conflict. The US Navy would have a much greater lead in the Indo-Pacific conflict. And of course, the US Navy has its own sort of army in its own service with the Marine Corps, and its own Air Force with the US Navy Air Wings, but also the Marine Corps has its own Air Force. So, the Navy kind of has that balance, which particularly for a China focus makes a lot of sense. But the overall proportion of US defense spending that goes to the Air Force does strike me as weirdly low, given how utterly essential it is to the war plans of both the Army and the Navy in pretty much any theater that they might face. It's a bit odd. So I think, frankly, that there is a degree to which the US Air Force just needs more money to be able to even close to meet its modernization and output goals. But it is also true that even within that, I suspect one of the consequences of being forced by the threat and by geography to move towards capabilities like the B-21 and the F-47, as well as the sort of collaborative combat aircraft and other things that they're working on, which are perhaps bring different sorts of integration, operational integration, and technological maturity challenges. But the net result is that something's going to have to give. And it probably means a significantly smaller air force than they currently have in terms of number of squadrons. Because fundamentally, geography in the Indo-Pacific and the threat nature of the PLA PLAF force you towards capabilities by necessity that are much more expensive per bit of combat capability you can actually get to where you need it to be than an air force essentially sized around enduring counterinsurgency support and tactical fighter operations in Europe and European airspace and CENTCOM. The US Air Force fundamentally is a tactical fighter force that has massive strategic mobility and some bomber task force capability kind of grafted onto it, as well as an incredible ISR ecosystem. But a lot of that tactical fighter force will really struggle for relevance in a fight against China in the Indo-Pacific. And so, barring an enormous budget uplift, you're going to have to trade off some of that other stuff if you want the sort of forces relatively quickly. And I say relatively quickly, it's still going to take a while. But such as F-47, V-21, all the different data links and other supporting enablers in electronic warfare. So, for example, EA-37B is a hugely important electronic attack asset designed for supporting the US CONOPS in the Indo-Pacific. Those sort of assets will need to be prioritized, and other things will have to give. The CCAs are interesting in the sense of collaborative combat aircraft. It's still a very, very difficult iron triangle to make, especially when you're dealing with those kind of ranges, unless you're launching from essentially land bases or maritime assets relatively close in, which creates some interesting logistical chains of, so how do you get them there? Who's launching them? How are you defending them as they're set up? How can you stay inside the Chinese kill chain? If they're trying to kind of set up and launch a couple of hundred CCAs from, atolls near the Philippines or something, that's pretty tricky. If you want them to go much longer distances, they're either coming off rails that are flying, so you're taking weapons capacity away from pretty scarce numbers of rails on combat aircraft that you're able to project to where you need them to be, with all those tanker dependencies and basing dependencies and logistical support dependencies. Or you need them to have a 1,000-mile-ish combat radius as well, in which case they're not going to be particularly small, and they're not going to be particularly cheap. And I think this is partly why you've seen Frank Kendall, for example, as a SACAF, talking about, Secretary of the Air Force, talking about, roughly a third the cost of an F-35, so $25 to $30 million, presumably. That's not going to be swarming anytime soon. These are the cost of an F-16 back in the day. And so, CCAs, a lot of the operational analysis stuff I've seen suggests that there's a huge amount of stuff you can usefully do with essentially smart weapons. So $2 to $3 million each, but that's coming off something else. So it's essentially smart weapons, smart decoys, stand-in jammers, loitering munition type effect, or essentially smart cruise missiles. But ultimately they are smart weapons. They're not really CCAs. And then there's some interesting stuff you can do at the high end, particularly things like penetrating ISR. But there you're talking about, at least $20+ million each. And even there, you probably want to go significantly north of that if you want it to be able to replicate the organic sense, lethality and offboard, so connectivity capabilities that a traditional penetrating combat aircraft would have. And if the reason you're going for these things is that you want them to be cheap, I actually don't think it necessarily works terribly well. At least I've never seen the operational data that supports that it actually adds up compared to spending the same amount of money and allocating the same number of people, because, of course, uncrewed systems usually require a lot of people to set up, to launch, to manage, to plan, to support, to certify, all of these things, to train with, than just putting that same uplift that you would need to roll these things out at scale into more standoff weapons, enablers, flight time, etc. for traditional stuff. I'm sure it can work because the US Air Force and others wouldn't be going down this road if there wasn't any good OA supporting it. But it's a difficult one. And this idea that just by going uncrewed and distributed, that you'll somehow end up with something that magically can go the distance, have comparable or even superior combat effects when it gets there, do so sustainably, and do so without a crushing personnel reallocation burden. Really hard to make it work. And a lot of this is based on faith rather than necessarily a winning formula that's already been discovered. It's based on partly this stuff has to work because all the other answers don't add up with the money available. I think some of the more promising stuff that I've seen is stuff, for example, that Boeing's been doing with Australia with the second phases of the MQ-28 Ghostbat program that they've been running for a while there. It's an impressive vehicle, but again, it's not particularly cheap, and you're still looking at either having to distribute sensors, weapons, data links between multiple platforms in order to have an entire kill chain or entire effects chain in one place. Either you distribute them across multiple things, and then you might be able to get the range that you need with the performance that you need, or you're going to struggle for range unless you make it significantly bigger if you try and put a sensor weapon on a single platform that can then still perform and still go the distance. So it's tricky. Looking at the Anduril and I forget who the other one was, which is terrible.
I just remember Anduril, but maybe before, because I think we've sort of failed to explain what the collaborative combat aircraft actually is and how is it going to work, because I think not everyone might know. And the way I understand it is that basically you will have a manned fighter jet like the F-47, but I think that they're supposed to already work with the F-35s as well, if I'm correct. And then you will have some number of basically drone fighter jets that will be following the manned fighter jet, flying and fighting with it. And to me, that sounds like completely fascinating and like quite a transformational technology. But can we maybe dig deeper into how it will actually work? Whether the pilot will be tasking the drones while in the air, or if they'll be completely autonomous and independent, and what role will they be playing, as you've already hinted, and I guess that depends on the finances, and what number of them will there be? And also from what you're saying, it sounds like that maybe the original plan or idea behind this program was that this could provide the quantity that will be needed for the Indo-Pacific. But from what you're saying, it sounds like that actually might not work as well in the way that it was originally planned. Thank you for listening to this conversation. If you'd like to hear the rest of it, you can find it on my Patreon. Click the link in the description or go to patreon.com/decodinggeopolitics. And if you decide to become a supporter, you get bonus content, Patreon-only episodes, and you will be able to ask questions to my future guests.